Alright guys, let's start on Chapter 4, Section 1. Now Chapter 4 is all about transformations, so we're going to use a lot of coordinate grid type stuff. So if you have graph paper, you may want to start having it with you every day. If you don't have graph paper, you can always use mine, but you guys are only in class 2 days a week, so I highly encourage you to go get some of your own so you can use it as much as you need while you're at home as well. But anyways, Section 4.1 is about translations, and usually students do very, very well this chapter, so you should do well too, but this is typically one of the easier chapters for people. So the first thing we're going to do is we're going to fill out some vocab, and first thing we're going to talk about is vectors. Okay, so a vector has both direction and it has magnitude. You will hear a lot about vectors when you go to physics, a lot about vectors. So vectors tell you what way it's going and how long it's going that way, or how far it's going that way. And we'll talk a little bit more about it here in a minute. So the initial point of the vector, as you could probably guess, is just the starting point. Okay, so vectors do have a starting point. You have to say where it starts. And then the terminal point, as you can probably guess, is the end point of a vector. Okay, so it starts at the initial point and it goes to the terminal point. All right, so the horizontal component is the distance the vector travels horizontally. And we're going to talk a little more about this here in a minute. And the vertical component would be the distance it travels vertically. Okay, so back to the coordinate grid. Okay, so we have a coordinate grid here. Okay, so this is my x-axis, this is my y-axis. And when I say the direction something travels horizontally, I'm talking about this way, right, or left. So that would be my x-coordinate I'm talking about. Left and right, how far left or how far right something, we're moving along the x-axis. Okay, and then vertical would be up and down. That's not a very good arrow, sorry guys. Up and down, and that would be my y-coordinate I'm talking about. So for further up, my y-coordinate gets bigger and more positive. For further down, it gets smaller or more negative. And then component form, all that does is it combines the vertical and the horizontal components together. All right, so let's look at example 1, and I'm going to talk about vectors a little bit more. So if you look over here, this is a vector, okay? So the way we would name this, we would name it vector JK, okay? This is not vector KJ. Okay, this looks like a ray, right? We have a starting point and it goes off forever in this direction. But it's not. This is a vector, and the context of the situation will make it very clear whether you're talking about rays or vectors. So when it's talking about a vector, this is going to be my initial point. Okay, and then this right here is going to be my terminal point. Okay, so how far left and right I go? So here I'm going right. This is my horizontal component, right? And then how far up and down? So from here to here, this is my vertical component. Okay, so all those vocab words is kind of on this picture. So this vector, we're telling someone we're starting at this point, and then we're traveling, and we are stopping right here. The reason there's an arrow on that one end is to tell us which direction it's traveling. Okay, so we would call it vector JK, and if I write it component form, I have these like carrot-like looking brackets. Okay, so think, when I go left or right, this is my X, this is my Y. So right here is my horizontal component, and right here is my vertical component. So all I'm going to do is count now. Okay, I'm going right 1, 2, 3. So I'm going right 3, right 3, and then I'm going to go up 1, 2, 3, 4. So right here would be a 4, and that represents up 4. So my first one here is left or right. Second one here is up or down. Now if I'm moving left, this would be a negative. If I'm moving down, this would be a negative. And of course, if I'm not moving left or right, it would just be a 0. All right, so I want you guys to look at these two vectors. Now these are kind of like in the same, but they are two different vectors, so treat them differently. And what I want you to do is kind of like we did on the first one, I want you to name it, and then I want you to try to put it in component form, and then we'll go over it and you can compare it to what I get. All right, guys, so this is what you should have got. So this first one on the left, we're going to call it vector CD. So we start at point C, and then our terminal point, we know it's our terminal point because it has an arrow, is at D. That's why it's CD. If you put vector DC, that is incorrect. Okay, and then this here would be the component form. Make sure you don't have just normal parentheses, because if you do, that's just a coordinate point, and we don't want that. This is how you show me you're talking about a vector. We're moving. Okay, so this means we're going left 5, and this positive 5 means we're going up 1. Okay, and then if we look at the one on the right, this is vector AB, so we're starting at point A, we're going to B, and this right here tells me I'm going right 3, and the negative 3 here tells me I'm going down 3. All right, guys, let's define translation. So this is kind of the big idea of section 4.1, and as we'll learn, we can translate something using a vector. Okay, but we can also translate stuff using a rule too. Okay, so a translation is when we take a function and we move it. Okay, so a function that moves every point of the geometric figure the same distance and in the same direction. Okay, so the geometric figure is not altered in any way, we're just moving it to a different place, usually on the coordinate grid. And we'll do several examples and you'll understand what that means. All right, so let's look at this example. Now I already plotted my triangle here, so go ahead and do that on yours. So the coordinates are given, A is 0, 3, B is 2, 4, and C is 1, 0. And it tells us that we're going to translate this triangle using the vector 5, negative 1. Okay, now let's recall back. This 5 tells us we're moving right 5, and this negative 1 tells us we're moving down 1. Okay, so we're going to move each of these 3 points right 5 and down 1. Now guys, make sure when you put these points on a graph, I know it sounds like super ridiculous, but make sure you label them A, B, and C. If you do it on a test and if they're not labeled, I would count them wrong, okay, or at least take some points off. So we're moving every point right 5 and down 1. So if I take A, I'm going to move it 1, 2, 3, 4, right 5 and down 1. So here's, I probably shouldn't have put that point there. Right 5 and down 1, and I'm going to put A with like an apostrophe. We call it A prime. Okay, so C, I'm going to move right 5, 1, 2, 3, 4, 5, down 1, and as you can probably guess, this is C prime. And B is going to move 1, 2, 3, 4, 5 right here. Down 1 would be right here. Erase that. And I'm going to call this B prime. Okay, so hopefully yours looks a little neater than mine does, but what you should be able to see is that triangle ABC and triangle A prime, B prime, C prime, these are two triangles that are congruent. The only thing that's changed is where they are located on this coordinate grid. The size and the shape has not changed whatsoever. All right, now we're going to translate this one using a rule. Okay, so this here, this is a rule. Okay, rule of, I'm going to put rule of translation. And this is it's pretty much the same thing as a vector. It tells us how far and what direction and how much we're moving. The difference is the way it's written. Okay, so what this is telling us is we are going to add 3 to every x coordinate. Okay, and think of it, if we're adding 3 to every x coordinate, we're going up 1, 2, 3. That means we're really just moving right 3 with every coordinate. And this y minus 1, that means we're subtracting 1 from every y coordinate. So that means we're moving down 1. Okay, so it's the same thing as a vector. It's just written a little differently, a lot differently. All right, so what I need you to do is go ahead and label these 4 points, plot them, and then label them A, B, C, D, and then we'll plot our new one after the translation. All right, guys, so your graph should look something like this. Looks kind of like a trapezoid, a sideways trapezoid. But all this is telling us to do is we're moving every x, we're adding 3 to it, so we're going to move right 3. Y, we're subtracting 1, so we're going to move down 1. So every one of these points is right 3 and down 1. So B, I'm going to go right 1, 2, 3, down 1. Here's my B prime. My C, I'm going to write 1, 2, 3, and down 1. Erase this one up here. So this would be my C prime. D is right 1, 2, 3, down 1. This is my D prime, and A, go right 1, 2, 3, down 1. Here's my A prime. So when I connect these dots here, and guys, this is really hard to draw on this tablet, so I apologize. Yours should look better, but as you will notice, these two are the same shape, same size, same everything. It just looks like we've taken it and moved it on the coordinate grid. All right, let's look at example 3 now. We want to write a rule for the translation shown below. Okay, and it's telling me we're going from ABC to triangle A prime, B prime, C prime. Okay, so this comes first, this comes second. Okay, this is our beginning product and our ending product. So what we would call this is our pre-image, and this is our image. Remember, pre-image always comes before image, just like, I don't know, pre-rep comes before the wrap. So that's how you know. So if I look down here, this is my pre-image, see, A, B, and C, and this is my image, which is A prime, B prime, and C prime. All right, now I just have to count what I'm doing. So and all these are the same, so I'm just going to look at point C to C prime. I go left 1, 2, 3, 4, so I'm going to write it in words. Left 4, and then I'm going up 1. And if I do the same thing from A, 1, 2, 3, 4, up 1, it'll be the same from A and B as well. So to write the rule, remember it's a rule, not a vector, it'd be x comma y, goes to x, and we're moving left 4, so that'd be x minus 4. We're moving up 1, so it'd be y plus 1.